So hi guys, welcome to HashiTalk Africa. Today I will be speaking on self-hosted CI/CD using Terraform. A quick introduction about me. My name is Adefemi. I think some or most of you are sort of like familiar with my name. I spoke last year and the year before as well. So I'm a DevOps engineer currently working at Swisscom, and you can always find me on Twitter with that info guy. For today, I'll just be walking us through 4 different things. One is a quick history. What are the tools that I used, the demo, and also the result as well. So quick history. What brought me to self-hosting my own GitHub Actions runner? The history is I use GitHub Actions a lot. I use GitHub Actions, I use GitLab CI, I use Jenkins, and I've always thought about it. Why can't I host my own GitHub Actions? Why do I have to always rely on the actions given to me by GitHub? Or what if I want to manage what my application is running on? Because with GitHub Actions, right, you run on a particular platform, on a specific platform. So either Ubuntu or a particular version of that Ubuntu, or maybe it's a different type of Linux variant, or maybe Mac OS or Windows. But what if I want to manage every tools that my GitHub Actions is running on? What if I want to manage all the tools? What if I don't want a specific tools? Because if you use Ubuntu, for instance, it gives you out of the box of what Ubuntu has. But what if I want something light, like Alpine? Like I want to have an Alpine image, and then I want to make sure when I'm running stuff, I'm the one doing this installation of everything. So I went down the rabbit hole and I started searching. What are the tools out there that does this? And I found 2 tools, which I will show you now. One of them is this guy. It's from this guy called My Young 34. Really nice project. And basically, the whole concept is that you run your own GitHub Actions runner in a Docker fashion. You can read more about this from his repository. It's kind of cool. I tried it out. It was awesome. But I wanted more. This was not what I was really looking for. I wanted something much more than this. I wanted something that gives me the flexibility to do whatever I want to do. Then I found this particular tool that is maintained by some people working in GitHub itself. So if you look at the people, right? So the name of the tool is called Actions Runner Controller. It's a Kubernetes operator that allows you scale and self-host your own runner for GitHub Actions, basically. This sounded cool. This was the perfect thing I needed. And like I said, it is developed and maintained by GitHub Actions team. And also, there are some external maintainers as well, or contributors. So this was the perfect tool I needed. This was the exact tool I was looking for. And then along the line, because with this tool as well, it also has, if you look at the releases, right, it also packages, you can deploy it using Elm. So it also has M charts. And this was exactly what I needed. I needed something that will allow me to use Terraform to deploy it, and then I can manage everything using Terraform. So since this allows me to use Elm charts, I know Terraform, there's an Elm resource from Terraform that I can use to manage my Elm charts and then deploy my Elm charts. So this was the perfect tool. Now, before you use GitHub Actions Runner Controller, you need something, you need your token. But one of the good things about this topic is that I've written I've written a blog post in the past, and you can follow this blog post. But this blog post does not use Terraform, which is why I am doing this. This demo for us. This blog post does not use this Terraform, basically. So let's go back to our demo, our presentation. So what are the tools I used? So some of the tools you've already seen I've stated in the past. So Kubernetes is part of them. Terraform is part of them to use to manage my my configuration. Elm charts, because this stuff is packaged in Elm. And also, GitHub, basically, because you use GitHub Actions to sort of like run this on the GitHub Actions runner, your CI on the GitHub Actions runner. So let's dive into it. Let's dive into the demo. Before you do this, you will need access token, personal access token, GitHub personal access tokens. In this documentation, I've did a good explanation of how to get your personal access token and what are the specific scope that you need to run this, to deploy GitHub Actions Runner Controller, basically. So I've done that here. And now let's dive into the Terraform part. So for the Terraform part, at the moment, I only have 3 things that you can run this on. So you can run it on AWS EKS, you can run it on Kind, and you can also run it on Minikube as well. For this demo, I'll be using Minikube. In my blog post, I use Kind, so you can use whatever thing that, as long as you can run the Kubernetes cluster on that particular platform, then you can use it. What else? So like I said, currently it's only supporting AWS EKS specifically. It supports Kind, support Minikube. So my goal is to actually make sure it supports other cloud platforms as well. And like I said, compared to the other project that I showed you from the other guy, from my Young, which is doing Docker and Docker, GitHub Actions Runner Controller moves much more than just deploying Docker in Docker mode. You can also deploy in the Kubernetes mode as well, which is mind-blowing. It's awesome. Yeah, so let's dive into it. So I've created some modules, some Terraform modules. So this one is the one, this Kubernetes chart manages the end release for the Actions Runner Controller, but also for the Actions runner itself. So we have the controller, and then we have the runner skill set. The controller is the one having interactions with GitHub and whatnot, and the runner skill set is the one where you are deploying your GitHub Actions. Let's put it like that. And then, of course, you have your variables and all. But one interesting thing is this that I figured out while doing this is this dynamic set. This is so cool. And what this means is if you have multiple parameters that are the same concept, then instead of you writing them differently or one after the other, you can use this dynamic set. So cool from Terraform. So, and as you can see, this is the variable basically that I'm passing. And this, like I said, different the variable, if you have a variable that contains name and value, then dynamic set is just best out of the box. So you have a list of objects and the name and value of those list and objects, basically. But also the same configuration is also for Docker and Docker. The only difference between the two is just the mode. So the mode is just a difference, which is where I have 2 different configurations. But of course, they both have the same concept. I mean, the Docker and the Kubernetes chart have the same concept. For Kubernetes, you need EBS. You need a way to store the. You need a way to attach volume to that Kubernetes controller that is running. So, which is why I have an Actions EBS chart. And like I said, for today, I'll be using Minikube as a demo. So let's jump to our Minikube. So in the Minikube module as well, we have some internal modules in the Minikube configuration. So we have the Actions cluster. So basically, Terraform also has a resource, a Minikube resource, and this is provided by this guy, Scott the programmer, also kind of cool, which is something interesting with the Terraform community, basically. So we have I created my Minikube cluster resource here, also like the variables and whatnot. And then, because like I said, you can deploy this in 2 different modes, Docker in Docker and Kubernetes. But for this particular configuration, I'm using, for this particular demo, I'll be using Kubernetes. So I have to follow the one that is managing the deployment using Docker in Docker, and also the one managing the deployment using Kubernetes. And for this, I'll be using Kubernetes to manage the deployment, basically. And if you come to our Kubernetes folder or folder, yeah, you can see I'm calling the Action Cluster module, and I'm listing out all this stuff that I've defined in the Action Cluster module, which is this guy. And if you look at the chart, I'm calling the EBS chart. And the reason why this chart is external is because these 3 charts, I'm calling them in every tool or every platform, let me put it like that. So this theory chart is being called into every platform in which they will be deployed into. So this is why they are external. And for each and every platform, the way the cluster is being created will be different. And what I mean is, if you look at Minikube, the resource for Minikube is Minikube cluster. If you look at Kind, for example, the resource for Kind is Kind cluster. The same thing for AWS as well, which is EKS. So which is why we have a common models among all platforms, and each platform have their own internal model in which they are being created. So let's go back to KS, to Minikube. So I call the ABS chart, call the arc chart, because I know for this particular one, I'm deploying it using KS, so which is why I'm calling the KS chart. And if you go to our variables, variables, these are just empty values, nothing has been defined, everything is defined using terraform.tfs. And yeah, I've set up like the Kubernetes version, the name of my cluster, the driver, Minikube driver. If you check Minikube documentation, you need a particular driver. For this particular one, I'm using Docker, sorry. Set up the amount of CPUs I need, the cluster disk size, the cluster memory, the nodes, also the EBS chart as well. Like I said, there are two different charts that has been needed. So this is the one for the arc system, and there's the arc runners, which is the specific runners, and which is the name. This arc runners is the name that then comes along with when you are creating your GitHub CI YAML file, you will need to use this name, which I'll show us. But also, if you remember me talking about this cool dynamic set thing, which I said will contain name and value. So because I know my chart, this is my actions arc corner chart, I need to make some tweak and some configuration. So some of the tweak are like the GitHub config URL, which I will show us where this is coming from. I created this repository to use for demo. The GitHub token, which this token will be deleted after this demo, the amount of runners I need. So the cool thing about this tool is also you can have a specific amount of runners running at a particular point in time. So you can have like the minimum amount of runners you want. So a particular runner will be available at a point in time. And then you can also have the maximum runners you want. So if, for instance, you are working in a team of 5 engineers, so you know each and every engineer needs maximum of 1 runners each. So you can say the max of runners, you can make it twice. So you can make the max of runners 10. So they won't run out of the 10 runners, and you can make the minimum, maybe 5, because 5 engineers. So depending on your configuration, basically, you can arrange that differently. And also, like I said, the container mode type, which is Kubernetes, but of course, if you're using Docker in Docker, this will be DIND, DIND, Docker in Docker. And also, these are some other configurations that come with setting up like I mentioned the other time, the volume claim, the storage class name, the kind of access mode, and the resource, the requested storage, basically, that is being needed. All these are configurations that can be tweaked based on what you want to, how you want to create it, in short. So let's jump to it. I'll delete this, and then I'll run Minikube delete -- all, because I already created one before now. And this should be fast. Okay, and then I'll just run Terraform. Let's check my history. Terraform apply, auto approve. So of course, this will create a Kubernetes cluster. If I open K9s, let me see, let me get created. So this will start the cluster creation. Like I said, I'm using Minikube, so it's going to create a new Minikube local cluster for me. Let's go back to the documentation here. So like I said, the repository is online. It's called Terraform GHA. So if you want to contribute, the only difference between what I'm doing and what Actions Runner Controller is doing is that I'm terraforming everything, if that's the word. But yeah, I'm terraforming everything. I'm using Terraform to manage everything that is being done here. And of course, you can manage it. You can do it directly. So in my blog post, I was directly running I think I do have that configuration somewhere here. Yeah. So I was directly installing this using Elm. But for this particular demo and for this particular repository that I have online, this open source repository, I'm using Terraform for everything. So let's check back, let's go back to our code, let's see what the progress is. So it is creating the cluster still. And in the meantime, let me try opening up. So I have a tool that I use to manage my cluster, which is called OpenLens. I think most people should be familiar with it. OpenLens. Yeah. So if I check KNIS, I use OpenLens and KNIS to manage my cluster. As you can see, this is Actions cluster. And if you remember, in our Terraform.tf verse, the name of the cluster is Action cluster. And you can see it's running the latest version of Kubernetes, which is 1.30. So the nodes are getting prepared. I think that's why this is still running. It's creating the nodes. Yeah, so why it is creating the node, what I can also run us through is some configurations of Arc. Let's go back to this. Let's go back to my blog post. Click on values.yaml. So in my blog post, I really wrote maxed out everything, what is being created, how it is being created. And if you check values.yaml, so like I said, these are the configurations that you see in my Terraform configurations. So if you see this place where I'm passing GitHub config URL, if you wonder where I'm getting it from, I'm getting it from here. GitHub config secret.github token, I'm getting that from here, .github token. But of course, you can also deploy this using GitHub app ID, installation and private key. But for me, this is like a long process. But this is if you're doing this in an organization way, this is the most preferred way. So you deploy a particular GitHub app, the installation ID, then the private key of that app, and then you run it that way. This is like the best preferred way. But since this is just running locally in my system, I just decided to use GitHub token. And also, you can set up proxy for this as well. So you can go deeper than what I've done to sort of like set up proxy and to set up proxy this and make it work. So the maximum runner, like I said, is the amount of runner there to scale in, will scale up to. So when you set the maximum at 5, that means the runner, you can only have 5 runners running at a time. The minimum runner, so this means the amount of runners that is available at every point in time. So by default, they're setting it to 0. You can also have a runner group. So think of this like if you have a Node application, you have a Java application, and you want to use different runner for them. So you can create different runner group for different application. So different runner group, one for Node, one for running Java, one for running, I don't know, Python, whatever. Depending on your configuration, you can do that as well. You can also attach some sort of certificate to the GitHub runner as well. So it goes like the configurations go deeper than what I have created with Terraform. But I mean, this is just like a bare bone, like out of the box, get it working, get it running is what I've created. And also the container mode as well. Also the container mode can also like you can tweak the container mode. So this is typed in, and by default, these are the things that comes with, if you use Docker in Docker by default, it comes with all this by default. But also if you use Kubernetes, which is the second mode, this is the end, this is Kubernetes. So if you use Kubernetes, these are some of the template specification that comes by default with it. But also the runner as well. So by default, it gives you this runner, but of course you can always change this image. This is like it's pulling an image from GitHub registry, but you can always change this image to your own registry. So you can use something like ECR, or you can use directly from Docker. So you can just put Ubuntu here and then it pulls Ubuntu, or you can put Alpine and then it pulls Alpine. So depending on what you want, if you look at my configuration, I am not using I am not using any image, right? Yeah, in my configuration, so I'm using the default image, so which is the one given by them. And I will show you that as well. So let's see configuration if this is done. So yeah, this has been applied. We have 4 added, zero change, zero destroy. And I'm just going to do something quick. I'm going to drag lens to this other screen. It's on my other screen. If I can find my if I can find lens. Okay, sorry guys, I'm trying to look for lens here. Okay, this should do it. So pods, drop this here. So as you can see, so this is Lens. It's also a tool to help manage your Kubernetes cluster and all. And so like I said, this should be closed. So because I installed some other things alongside the Actions Runner Controller, this is the action system. This one is the one communicating directly with GitHub and also watching some of the changes. We have metric server. For this, I'm just using it to get metrics. So this is the local PV provision and the storage provision as well. So, and this is the main, we have the listener. So this one is the one listening to the configuration that is going on in GitHub. And this is the runner. And if you remember my configuration from Terraform, I said I want minimum of one runner. So which is why in Lens, let me put this here, which is why in Lens, you can see that it's just one runner that is active at a point in time. And if you look at the configuration of the runner, if we see the image it is using, image, where is it? Yeah, so if you see the image it is using, I told you it's using the default image. So this can be changed. You can put Ubuntu here, whatever image you want to use can, of course, be changed. But just know that the image you're using, if it doesn't have the tool that is required, then you need to install that particular tool. So how do we test this? Now we have Actions Runner running. How do we test it? Before now, I've created a simple application. Basically, what does this application do? Is a mathematics application. So I have 4 different functions that is doing basic arithmetic. So addition, multiplication, subtraction, and division as well. And then I've also written some sort of little test in there that is doing addition, multiplication, subtraction, and I'm using TypeScript to sort of like test this out. Of course, you can use any programming language as long as you're gonna support it. And I've created a GitHub Actions, GitHub workflow. And what this does is, at first, it delays the runner in a particular second. The default is 2, but this is not required. You can use anything for this. You probably don't need this too as well. And then in my job, if you remember, if you are creating a GitHub workflow, when you specify the platform you want it to run on, you either put Ubuntu or your specific operating system. But for this, I'm putting Arc runners. If you remember, I told you the name of this will be the name of your where you want your job to run on. So, which is why in this place I have Arc runners, because when I named the Arc runner namespace, I call it Arc runners. So any name you pass in here will be the name you pass in this runs on. So basically, I'm installing Node, checking out the code, installing Node, running npm CI, and then running npm test. So basic stuff. Now let's go to our code, which is this guy. You remember I told you I will show you the runners, right? That the runners that is being created. So if you are self-hosting your runner, you click on these runners. When you click on runners, you will see the one GitLab is giving to you for free. So this is the one GitLab, I think is the standard GitHub hosted runner. It's the one GitHub is always giving to you. And if you are running on enterprise or something, then you have this one that has 64 cores and this large amount of storage. But if you're self-hosting, you come to the self-hosted runner tab. And as you can see, currently there is one available runner, which is the one I have self-hosted. And these ones, I think they are from the past because I was playing around doing samples just to make sure this stuff work before the demo. Yeah, so these are really actually not available. They are not available. These are just like the runners I've hosted in the past. Because if you see the date as well, it's like in the past. And this is the runner skill set, basically. So this is the one that I've deployed right now that is ready to pick up the job. So let's go to GitHub Actions. I have this workflow here. And then what I will just do is I'll click on run workflow. I'll change this to 1 second. And I'll click on run workflow. And then we should have a new workflow starting any minute from now, this guy. So, and if you look at, if I click on test job, it will starting job. It said it's picking up what? Job is about to start and picking up this runner. If you look at my lens, you see that that runner is this one that is currently available. And if you see the runner P8S, let's see what this runner is called, GCW8S. So GCW8S, this one. So the interesting thing about this is once a runner is done with his job and it is successful with his job, it deletes it. So it deletes that runner and then bring back a new one. As you can see, that runner AWS is gone, and then there's a new one that has just started about a few seconds ago. So there's a new one that started 34 seconds ago. So once it's done with a specific runner, it brings up a new runner, and then that new runner is also ready to pick up a new job. So the wait time is kind of slow. It's kind of little. So you don't have to think of wait time or something. The wait time is little. I mean, you won't notice the wait time. That's just basically what I'm trying to explain. And if you go back to our GitHub Actions that we've just run, you see it runs, it installs Node, runs npm CI, does my test, and all my tests run successfully. And then it just cleans up the job. Voila, everything works out of the box. So let's go back to our presentation. So you might want to ask me, yeah, all fine and good, but what is the result? One, you've seen this is cheaper. You don't think of how many actions you're running. You can be running your GitHub Actions runner locally on your system. Also, you can tweak your runner. Like I said, if you want to use a very, very small image, like Alpine or something, you can tweak your runner to use that particular image. Also, think of testing. If you want to test a large suite, you can easily spin off any runner, test your large suite, large test case, and delete it. But don't forget, most of everything that runs on this is ephemeral. What does that mean? That means it deletes after it is done. So if you need a result of something, what our advice is, you can attach a particular volume to your runner and then store all your anything you will need, you store it into the volume, and then you can use it later. But if you don't need anything for the volume, you can do it like that. Or you can either push your results to S3 to a particular bucket or a particular storage, and then pull it back when it is being needed. I mean, those are some of the compromises that needs to be made. Another good thing is if you run a startup and you ever think of, oh, I spent so much on GitHub Actions, blah blah blah. This is something you can just create something in EC2, like run it in EC2, and you only need to figure out how to manage the infrastructure. And Terraform is there for you to manage that. So you don't have to think of, oh, how do I manage this? How do I increase the volume? How do I increase the storage? Terraform is there for you. Yeah. And there comes the end of my talk. So thank you guys so much for listening in. I hope this wasn't boring. If you have any question, of course, you can always reach out to me on Twitter. Also, you can always go to the repository, contribute to it if it interests you. Yeah, that's all. Thank you.